So in our last lesson, you guys, we learned how to solve a system of equations by using the graphing method. What we did was we graphed two equations on the same plane, and if they crossed, there was a solution. Their solution was wherever the coordinate was, or where the two lines met up. Or there was a situation where we had the same slopes but different y-intercepts, and we said that that was going to be a no solution. If you graph that one out, they would make parallel. They were two parallel lines that make like a ladder or a train track. Okay, and so they never cross, so they would never have an answer. And then the third situation was when we had two lines that looked exactly the same, that they were identical pretty much, or they coincide, and we would say that that had an infinite solution. So there's what I'm teaching you today is I'm teaching you how to solve by the substitution method, which is the second method you could use. There's basically what happens here is I'll ask you to solve a system of equations, and you'll, at the end of this first part of this chapter, you'll be able to know how to solve a system of equations with three different methods. So you'll find your own method that you like the best, and I'm just here to show you what those three methods are so you can figure out which one works for you. Okay, so let's start with the substitution method, and the good thing with substitution is that there's no graphing involved. It's all algebra. Okay, so for the substitution method, my suggestion is to look at the four letters in each problem. Okay, so the four letters in each problem, like in number one, here's one letter, 2, 3, and 4. Okay, and you want to look at them and find one that doesn't have a number in front, or that has 1 in front. Okay, so in this set, we have two options. We see the y in the first equation has no number in front, and we also see that the x here has no number in front. It doesn't matter which one you pick, but maybe because this y is first, let's pick this one. Okay, so the idea for substitution is that you look and see which number, or which letter, I'm sorry, has no number in front, and your goal is to take that. Once you figured out which equation that is, you want to solve for that letter. That's why I circled it, okay? So for this first equation, because there's no number in front of y, I'm going to solve for y. So I'm basically trying to move everything out of the way and get y by itself. Okay, so if I did that, that means I would have to subtract the 2x over. Okay, in that first equation, and so I would end up with y equals negative 2x plus 9. Okay, so once we solve for y again, you guys, because it had no number in front, or it had a 1 in front. Okay, that's what substitution is. You look for that out of the four letters they give you, look for the one that has a 1 in the front. Okay, now what we do is we go to the second equation, and basically what has happened is we know now that y is negative 2x plus 9. So in this second equation right here that I'm putting a star at, basically it's saying that everywhere you see a y, you're going to plug in negative 2x plus 9. So let's rewrite the second equation. I have x plus 4, and then, oh, I have a y here. So remember, when I have a y, basically that tells me I need to plug in negative 2x plus 9. So instead of putting y, I'm going to put negative 2x plus 9, or I'm substituting negative 2x plus 9, and then equals 1. Now all you're doing is solving. Okay, so you know that this 4 is going to distribute, and, oops, let's go distribute there. So I would have okay, and then now all you want to do now is you just want to start solving for x. So x minus 8x is negative 7x plus 36. Let's go ahead and get rid of this 36. So we subtract 36 on both sides. These guys cancel, so I have negative 7x equals negative 35 divided by 7, or negative 7. So x equals positive 5. Okay, unfortunately we're not finished yet, so we still need to figure out what y is. So to figure out what y is, you guys, you go to the equations. One of the equations, you can either go to the this one, or the one that you altered. Doesn't matter, but you gotta pick an equation, and everywhere you see an x, you're gonna plug in a 5 because you need to figure out what y is now. Okay, so for all of these problems, you guys, you should have two answers. Because you need to figure out what x is and you need to figure out what y is. So please don't stop here because I can't give you full credit for that if you stop right there, okay? So let's work with maybe this one that we adjusted here, this one, okay? So to solve for y, now that I know what x is, I go y equals -2. I know that x now is 5 from what I solved down there. Okay, so I have -2 times 5 plus 9, and now I just solve. Okay, so y equals -1. Okay, so my answer for this, if I was to kind of make it look like yesterday, remember we put it in a point format, and the point goes x comma y. So my x is 5, and my y is -1. So final answer for this is 5, -1, just like that. Okay, pretty easy, hopefully, kind of. Okay, let's look at number 2, you guys. Another special thing here to remember is that when you look at these equations, so here's equation A, here's equation B. When you look at the equations, you can only have one of each letter in the problem, okay? So if you look at like this 2a here, see how I have x minus 2y equals y? I have a problem right now because I can't have a 2y and a y there. So what I would need to do to be able to continue with this problem is combine the y's together. So maybe let's subtract a y over maybe. So if I subtract a y over here, I subtract y, so those guys cancel out, so what I would have is x minus 3y equals 0, and then this bottom one doesn't change. Okay. Now I repeat with just like what I did in the other problem. Let's look and find a variable that doesn't have a number in front or has 1 in front, okay? So my choices are here, 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 or here. So the only one that applies to is this first x, right? It's the only one that doesn't have a number in the front of it. So what that means is I'm going to solve for that variable, okay? So to get that x by itself, I have to add the 3y over. So my new equation for that first one would be x equals 3y, okay? What does this tell me? This tells me now when I go to the second equation, everywhere I see an x, I'm going to have to plug in 3y. So let's rewrite our second equation. And then looking for an x, I find an x right here, right? So since I found an x right there, basically I'm going to substitute it out, and I'm going to put a 3y there instead of an x. Okay, so let's solve this out. 2 times 3y is 6y, minus 5y equals 4. 6 minus 5 is 1, so I just have 1y equals 4, so I found out what the y part is. Remember, I'm not done yet. I still have to figure out what x is. So let's bring this, I like using this equation. Let's use this equation that we changed up right here. The x equals 3y. And so now I'm going to plug that in here. X equals, okay, I'm being lazy now. Let's just do this down here. So x equals 3 times, we know y is 4 now. Solve it out, x equals 12, okay? So let's put it in a point format. Remember, it looks like that and like that. Here's my x, here's my y. So it would be 12, 4. Okay, If you wanted to check your answer, you guys, all you have to do is just take these coordinates and plug them into one of the equations, and you can check your answer to see if you're right. Two more examples and then we'll be good to go. So this one I kind of helped you out here because this y has no number in front or has a 1 in front, and I already moved everything over to the other side. So basically I helped you out a lot with this one, okay? So there's no need to move anything around because since this y is by itself, all this is saying is go to the second equation, 8x minus 2y equals 20, and wherever you see a y, which is right here, substitute it out for 4x minus 5, okay? Because in this first equation it's telling me wherever you see a y, it equals 4x minus 5. So I'm going to take out that y in the second equation and put in a 4x minus 5 there. So let's do that. So I have 8x minus 2, and I don't want to write that y in, so I'm going to substitute that out for the 4x minus 5. Okay, and then that equals 20, and now all we do is solve. Okay, so this distributes. Don't forget this negative 2 times the negative 5 is going to make this plus 10. We distribute the negative in 2. Okay. And then what do we have here? So if we reduce this out, I get 8x minus 8x, they cancel out. And then I'm left with 10 equals 20. And we have a problem here. Is this true, you guys? Is 10 equals 20 true? It's not true, right? That this statement is not true. So 10 does not equal 20. So this is a false statement. So it didn't work out as easy as it did with 1 and 2 because since the variables canceled out, we ended up with an issue here. So sometimes when the variables cancels out, you'll be faced with two decisions. You got to decide if the statement is true or if it's false. So again, if you cancel out all of the variables or all of the letters, you're left with two situations. You got to decide if it's a true or false statement. In this case, it's false because 10 doesn't equal 20. Okay, so at this point, if you are able to look at this and you can see that it's false, this is our no solution when we're doing substitution. Okay, so if you work this out, all the variables or letters cancel out, and it becomes a false statement, it's not true, then our final answer for the problem is no solution. You don't have to continue on with the problem. Okay. Now, I have a number 3 here twice, but this should be number 4. Moving on to number 4, let me show you what will happen with number 4. So, looking at my 4 letters, 1, 2, 3, 4. Oops, that's not a letter. 3, 4. There's my 4th letter. I find the one that doesn't have a number in front of it, which is this guy. So I'm going to move everything over. So I'm going to have negative y equals subtract 2x, subtract 2x. Remember, we want to put that x term in the front. That's why I have it before the positive 1. I have a problem again. I don't like having a negative y. So remember, just like what we did yesterday, let's multiply both sides by negative 1 so we can change all the signs. Okay, so my new first equation is going to be y equals 2x minus 1. What does that tell me? When I rewrite my second equation, so here's my second equation, 3y plus 3 equals 6x. Wherever I see a y in the second equation, I'm going to sub it out for 2x minus 1. Okay, so let's look at that change. So I have 3, and then instead of y, I'm going to plug in 2x minus 1, and then continue on with the rest of the problem. Plus 3 equals 6x. Solve out, solve. So I go here to here. 6x minus 1 plus 3 equals 6x. Did I mess up here somewhere? Ooh, I know. When you distribute the 3, and this isn't going to be 1, this is going to be 3. There we go. So 3 times 2x is 6x. 3 times negative 1 is negative 3. So if you look at this, you guys see how the 3's cancel out. So this negative 3 and that positive 3 cancel out. So what I'm left with is 6x equals 6x. And is this a true statement, you guys? Can 6x equal 6x? It's true, right? They're both exactly the same. We know that when when the thing is exactly the same, just like yesterday, we say that they coincide or that it's infinite solution. Okay, so the third scenario, this is what an infinite solution would look like, you guys, when you solve this algebraically. Again, both sides end up looking exactly the same. In a no solution, you cancel out all the variables and then the statement ends up being false. It's not true. Or it could be like numbers 1 and 2 where you work it all out and you're able to get two numbers that you could solve out. Okay, so the key thing here is to, if I had to summarize this for you, you need to, one, look at all of the 4 letters in the problem and see which one has a 1 in front or doesn't have a number in front of it and solve. Then you go and substitute. Once you've solved, substitute that other side of the equal sign into the second equation and then solve again. So it's just kind of like, the key thing for this is that it's called the substitution method. So you got to substitute. If you're not substituting anything, then we have a problem and you're probably not doing it right. If you want to check your answer one more time, if you look at number 1 here in the box, the 5, -1, you can go to any of the 3 equations, the 2 original ones or the one you fixed, plug in 5 here, plug in -1 there, and solve it out and see if you are able to get both sides equal to each other, and that's a quick way to check. Okay, so that's all I have for today. Don't forget to take the quiz.